In the previous video, we have seen about the introduction part of the solution. Now I am going to list out some important topics that we are going to deal in this chapter, and these topics are important for your board as well as for JEE and NEET also. So far we have seen first topic as our introduction part, that is completed. In the previous video I have given lecture about it. Now next topic we will see types of solution. Here we will see how many types of solution are there on the basis of solvent. There will be three types: solid, liquid and gaseous solution. After this, a very important topic for board and for JEE and NEET, that is concentration terms. Concentration terms. Terms like normality, molarity, molality, mole fraction, which we have already studied in 11th science, but here also we will see a detailed study about that, and these are very important terms for your practical also, for your board and for your JEE and NEET. Then we will see solubility. In solubility, we will focus on Henry's law. Henry's law will be studying for gaseous solute in liquid solvent. Then after this we are going to focus on vapor pressure. In vapor pressure you will be seeing Raoult's law. Raoult's law for two kinds of solute will be there: volatile solute and non-volatile solute. That we'll discuss later. After this, important topic, colligative properties. Colligative properties means those properties which depends only on the number of molecules. It does not depend on the type or which type of solute, which compound you have taken. It just depends on the number of molecules, how many molecules or atoms are there, on number. In this you will see four properties. First, relative lowering of vapor pressure. Second, elevation in boiling point. Third, depression in freezing point. And last, osmosis. These four are very important part of this for properties of this chapter, and this contains some numerical part also that we'll discuss in the later part of the video. After colligative properties, we will be seeing abnormal mass. Abnormal mass, or you can say experimental mass. Determine experimental mass in this using various techniques, and here you will come through a factor called Want Hoff factor. So this is a summary, you can say, or the topics which we are going to see in the whole chapter. Introduction part is already completed, and then we will see all these properties in this chapter. So let us begin with the first topic, that is what? Types of solution. Okay, here are types of solution. So types of solution are based on the physical state of solvent. If the state of solvent is solid, it will be a solid solution. State is liquid solution. State is gas, it is a gaseous solution. So on the basis of the physical state of solvent, solutions are classified. First you can see solid solution over here. Here solute is in solid state, solvent is also in solid state. So examples are alloy. So alloy is a homogeneous mixture of solid solute and solid solvent. Example, gold. When you mix copper in gold, you will have a alloy of gold. Second, solute will be in liquid, solvent will be in solid state. A simple example is amalgam. Amalgam is nothing but it's an alloy of mercury with any metal. Example is zinc amalgam, means in solid state zinc will be there and in liquid state we will have mercury. Other example of amalgam, you can have sodium amalgam, in which sodium is solid, mercury is liquid. Third, we have solute in gaseous state, solvent again in solid state. A very simple example, adsorption. Adsorption means on surface of any metal, any gas adsorbs. So only on the above surface, it doesn't go inside the bulk phase, it remains only in the upper phase. So this is called adsorption. So adsorption of H2 gas on palladium metal, you can say platinum metal also over here. So these are solid solution in which solvent is in solid state and solute are in solid liquid gas. Third one, next one we have liquid solution. So here you will have solvent in liquid and liquid state. First case, solvent is in liquid, solute is solid. A very common example, you can have sugar solution or salt solution. When you mix sugar or salt in water, you will have a liquid solution. Then you will have liquid and liquid. A simple example are ethanol and water, when you mix alcohol plus water, or you can simply add water to milk plus water, example of liquid solution. And then gas and liquid. In daily life we consume cold drinks in which gas is pressurized in a liquid, or you can have example of oxygen dissolved in water. You can see in rivers, seas, lakes where oxygen is dissolved in water. So gaseous solute in liquid solvent. Third case, we have gaseous solution. Here we have solvent in gaseous form, solute can be solid, liquid or gas. First case, when you have solute in solid state, solvent in gaseous state. Example is smoke. You can also take example as dust. When you can see smoke has some dusty solid particles inside it in the gaseous air. Camphor, it's a cubical substance which is also called kapoor. So camphor in nitrogen gas, also example of gaseous solution. Other example are dust, where you can see small tiny solid particles spread in the gaseous atmosphere. Then you have liquid in gaseous, solute is in liquid state, solvent is in gaseous state, moisture in the air. We know during rainy seasons we have small droplets of water in the air, so it is called liquid in gas. And last, very simple, gas in gas, solute also in gaseous state, solvent also in gaseous state. Example, air around us where nitrogen, oxygen, carbon dioxide, all different gases are mixed together. So these are the types of solution which are based on the physical state of solvent. If solvent is in solid solution, liquid solution, gaseous solution. This is not very important topic, but just for your information, this is good topic. You should remember the examples based on the type of solution. Okay, so we have seen types of solution. Now we'll move to second topic, which is very important, and that is concentration terms. Students, concentration means what? Focus. That is different thing. Here concentration in chemistry means what? How much amount is present, how much amount of substance is there in a given solution. That is called concentration. For example, you cook something, you add some ingredients in the proper amount and fixed amount in it. That is called its concentration. So to define concentration, we have a definition on board. Amount of substance present in a given per unit volume of solution. Suppose you take 1 liter of solution. In this 1 liter of solution, how much solute is present? Suppose 10 gram solute is present. To show this, the amount in terms of concentration, we have various terms. You already know some normality, molarity, formality, molality, etc. So concentration means how much amount of substance is present in a given per unit volume of solution. And yes, wait, only one exception case for concentration definition, amount of substance present in per kilogram of solvent. solvent term is used only when you have a term molality. For rest all the concentration terms you will use volume of solution, but only for molality you will check the weight per kilogram of solvent. So now we are going to see some concentration terms over here. Let me write first all the terms over here which we are going to study in detail. First term which we'll see is percentage weight by weight. It is also called mass percentage. You will have percentage weight by volume also, or percentage volume by volume. The numerator will show the solute weight and the numerator will show solution. We'll see in detail in the further part. Next, very important concentration term, molarity, which you have already discussed in your 11th science syllabus and is one of the most important topic or term used for defining various concentration terms. Third, you will have molality. Okay. Then we are going to have normality, then mole fraction, then we are going to discuss on ppm. Friends, ppm means parts per million. This term is used when the amount of solute is very less in your given solution. And there are further topics like strength, formality, etc. But for your board, molarity, molality, normality, mole fraction are very important. From these also questions might come, but for J all these terms are very important. So one by one we are going to see all the different concentration terms and we'll see numericals based on this. So dear students, here you have seen the overall of concentration terms. These are the concentration terms over here. In the further part, I will divide these concentration terms in two parts. So out of all the concentration terms, I have segregated these terms in two categories, related to mass, related to volume. Related to mass, you can say percentage weight by weight, mole fraction, molality. In these three terms, you will see the term mass in it. And related to volume, molarity, percentage weight by volume, volume by volume, normality. Here you will see the term volume in it. As you all know, where there is absence of volume term, only mass terms are present. So these terms does not depend on temperature. Whether you change the temperature, these terms will not change. But here, if you alter the temperature value, the value of these terms also will change. So these are the concentration terms which we are going to study in the chapter. And my dear students, the next first concentration term which I am going to start is percentage weight by weight, which I'll show in my next video. So I want you all to see this video, watch this video carefully, start making notes of it, and after this see the next video. There I'll give you some numerical part also. Try to practice it. Thank you.